Hello everyone, welcome back to BC Calculus. We're still in lesson number 32, where in this video we're going to talk about density functions. So the key idea here is that we're going to be slicing based on density rather than shape. And if you guys look at some of the examples that we give here in the notes, population density is a really big one that we do. We would say it's people per mile along a road, people per unit area in a city, or sometimes we could even talk about, with biology, bacteria per centimeter cubed. The density of a substance, which would be air, wood, metal, is the mass of the unit volume of a substance, and it's measured in units such as grams per cubic centimeter. What we're going to end up doing today is look at two basic examples of density, and we're going to look at them here. What we really want to do is just look at breaking up our pieces, our shapes, into different regions, and we're going to add up these contributions. That's how we're going to get our integral, and then we're going to look at the units to figure out what our work will entail. So for example number 10, it says Quadville is a city in the shape of a rectangle, as you guys see here. 5 miles on one side and then 6 miles on another. There's a highway that runs along the side that is 6 miles. So our highway is going to be here. So there's my highway. I don't know why it looks like that, but that's my highway. And the population density, x miles from the highway, is given by P of x equals 20 minus 4x. And so this is going to tell us what the population is as we move further and further away from the highway. And this is in thousands of people per square mile. So the units of this is in people per square mile. So what's the approximate population of Quadville? So we want a population. So our answer that we want is going to be people. We want our unit to be people. Our density function, we've actually already said, is in people per square mile. So I can go ahead and move this right there. So that's going to be what our units are. In order to get our problem set, then we need to multiply our density function times miles squared in order to get back to people, right? So people per mile squared times mile squared gives us back our people. So we're going to go ahead and draw ourselves a rectangle, and we are going to slice it up. And the difference that you see here, this is going to be our delta x. And so we have an n amount of rectangles that we can actually create here. And if we look at this, the delta x is going to be represented by, and let's just say that this n is the number of rectangles. So our delta x is going to be the total 5 divided by the number of rectangles that we create. And so the length of this is simply going to be 6, right? If we want to find the density, we're going to find the area of these shapes. So 5 over n, and then this length is going to be 6. So if I look at this, my population of each slice is going to be the people per mile squared. Well, that's going to be our density function that you will always be given. So this is going to be 20 minus 4x. That's a minus. We're going to multiply that by now area. So in work that we talked about before, it was all about volume, right? It was the weight times our volume of our cross section. Well, one of our slices is simply a rectangle, and we want the area of this thing. So no matter which rectangle we choose, the distance is always going to be 6. This length is always going to be 6. So I can go ahead and substitute in 6 here. And then our miles is going to be 5 times n. So whatever this distance is. So this right here would be whatever 5 divided by the number of rectangles that we have. So 5 over n. So if I want to find the total population of this particular problem, then I'm going to multiply all these things together, because again, if I multiply all these things together, I'm going to get people per square mile. The miles are going to cancel out, and I'm going to be left with people. So it's going to be 6 times 5 over n. Now, this is the summation of all of these rectangles, where n, again, is the number of rectangles. But you guys have learned before, and as we've always moved from a sigma notation to an integral, I'm simply going to multiply 6 times the 20 minus 4x. And we've already said that this 5 over n is represented by dx. So this is simply going to be dx. And so we're just going to integrate 6 times 20 minus 4x times dx. And that's going to give us that this is going to be 300, but our units are in thousands of people, so this ends up being 300,000 people. So 300,000 people are represented in this city based on the population density that we're given here, and again, our proportion of our actual city. So the difference again with volume is that, with work was volume. Density, we look at area. We look at one little slither, one little rectangle, or one little shape and figure out what the area of this thing is. Well, this is just going to be length times width. Let's look at the next example. And example number 11 says the population density of Regensburg is the function of the distance from the city center. And so what these problems essentially does is gives us an idea of how much our density is and as we move further out of our center. So the function density is given by the square root of 36 minus r squared and thousands of people per square mile. And the radius, Regensburg has a radius of 5 miles. And we want to estimate the total population of Regensburg, I should say. So what we want to do for this particular example is we want to look at, again, taking the fact that population of one ring. So we're going to create ourselves one ring, which is what you see right here. And we want to cut it and we want to flatten it out. We're going to flatten out. And again, the more rings I do, the delta r is going to be our change in our radius from our center. So this is going to be a change from where we're here to here. That's a change in radius. This is another change in radius. So as we add more and more rings, we get more, the thickness of our ring here is just going to be dr. The length of this thing is going to be the circumference of a circle, right? It's going to be 2 pi r. So that's going to be how we're able to cut this, slice this, and find out what this is. So the area of this any of my regions that I want is going to be 2 pi r times dr. And so that's going to be my area. Well, that's all I'm going to do here is I'm going to multiply 2 pi r times my change in my r, and I'm going to multiply that by what PR is. And so if I do that, guys, I can see that this is going to be people per mile squared. This is going to be miles, right? This distance is in miles, so how far away is it? And this circumference, this travel we're traveling is also in miles. So just like before, our miles are going to cancel out and we're going to be left with people. So our total population is actually just going to be this entire thing again. The only difference with this is that instead of the dr, we're going to rewrite this as, again, that this is 5. So no matter how many rings that we have, our dr is going to be represented as 5 over n. And if this had been 10 miles, it'd be 10 over n, because I can create an infinite amount of rings in my town. So this is going to end up being 5 over n. And again, my function, it's going to be the square root of 36 minus r squared. You guys are not going to be responsible for having to write the sigma notation part of it. All that I need for you guys to do is just talk about actual population. So we're going to have the 2 pi r. Again, we're going to have this as times our function, which is 36 minus r squared. And then this, again, we're going to rewrite this as dr. And so that's what we're going to do for these problems. Again, it's all about area. And then it's going to be times our population, right? Our density function, which is going to end up being 375,980 people. And again, we know that these miles here are going to cancel out with these, and so this should give us in units of people. And that is all that you have to do. So that's it for our lesson 32. We talked about work and density. I will see you guys in the next unit with our next lessons.